Hello everyone. So today we are going to cover another interesting problem, intersection of two linked lists. So here they are given a linked list which is linked at some point. That is, for example, consider the first linked list which is starting from A1, A2 and C1, C2 and C3, and the linked list 2 is starting from B1, B2, B3 and passing through C1, C2, C3. Here the linked list A and B connect at the point C1, we have to return C1 as our output. So again, the second example starts from 4 and ends at 5, and linked list B starts from 5 and ends at 5. In between, it connects at 8. So that is the node we have to return as our output. So how are we going to approach this problem? As we always do, if it is a linked list problem, the first intuitive solution that stuck our mind is going to be two pointers. We always choose two pointers to first approach the problem of linked list and then move to check if there is any efficient or optimal solution available. So here the same way, I'm going to have two pointers, that is pointer first which is going to point at the linked list A, and pointer second which is going to point at my linked list B. For example, if a person is trying to travel by two routes, the first route starts from some point and goes till the end. The same way, a second person is planning to travel another route that starts from some point and reach towards some end. Now, the first person is planning to travel the route 2 and the second person is planning to travel the route 1. So now the first person starts traveling the route 2 now. He comes till some point. He finished first because there are only lesser stops. So he started this route early. And the second person who completed a bit late than the first person because there is one more extra stop, then he starts traveling the first route and he reaches some point. It is very similar to something we already did, which is whether the linked list having cycle or not. In that, we have considered two pointers, one is fast pointer, another one is slow pointer. As both the pointers travel towards the linked list, at some point they're gonna meet. The same technique, as one's size is greater than the other's size, we're gonna traverse by using pointer F first. We are going to traverse the path 1 first and then start the second path. The same way, by using the pointer S, we are going to travel the path 2 first and then the first path. At some point they're gonna meet. If they are meeting, then we are going to return the node where it meets, and if they are not meeting, we are going to return null. So let's go for a dry run with this example so that we'll understand how it is going to work programmatically. So now we are checking every time if my node F is equal to node S. If they are equal, then return that node. In this case, it is not equal, so we are moving F to the next node. And yes, also to the next node. We are now checking whether they are equal. No, they are not equal, so we are moving F to the first node and S to the next node. Sorry, F to the next node and S also to the next node. So now they are not equal again, so we are moving F to the next node and then S to the next node, that is traveling from here to here. So now F is at 2 and S is at 3. They are not equal, so it's time to iterate again. So F moves to the last node and S moves to this node. So now here also they are not meeting. So in this case, F has finished traversing its path and reached the null pointer. So in this case, what are we going to do? We traveled the first linked list. Now it's time to travel our second linked list. So our F is going to point at the first node of second linked list and S is going to iterate and move forward. So now S is going to point at node 5 and F is going to point at a second node 9. So now our yes has reached the last node, that is after that is going to be null. So it's time to travel our first linked list using the pointer yes. So now moving the pointer yes to the first node of the linked list. So now we are checking whether f and s are equal. No, they are not equal, so move one pointer next. So yes moves to here and f moves to here. So in this case, we are checking whether they are equal. No, they are not equal. So move them one pointer ahead. So now yes is pointing at node 3 again. F is pointing at node 3. They both are equal. So in this case, return node 3. So yes, we have achieved a solution using two pointers. As usual, we always do linked list with two pointers, and in this case, it is really helpful. So now let's see how we're going to code it. As we saw examples, directly go to code. So they are given list node head A and head B. We are first checking whether the first node itself is a connected node. So we are going to check if head A is equal to head B. In this case, return any node because we have to return the connected node. If not, I'm going to declare my two pointers. First is going to point at our linked list A, and second is going to point at our linked list B. And we are going to iterate it till it meets null. And we are going to assign the node first with a value. Every time we are going to check if our node first reached null. If it reached null, then it has to point the second linked list head. So in this case, we are going to point head B. If not, it is not null, we are going to move it ahead. First is equal to first dot next. Simple. Same way we are going to check. We are going to move every time second to second dot next. Second equal to second dot next. When second is not is equal to null. So we are checking if second is equal to null, then assign head A. If not, move it one pointer next to the second. So every time we move the pointer, we are going to check if first is equal to second. Then if they are equal, then return any node. I mean, because they both gonna point at the same node, so either first or second is gonna be equal. If not, finally we are going to return null if we didn't find them equal at any point. So let's run. So yes, let's submit and check. Yes, the solution is accepted. It runs in 1 millisecond. So thanks for watching the video. If you like the video, hit like and subscribe. Thank you.